The next library we're going to be looking at is the FPDF library, and this is one of the libraries that we're going to be using in the programs that we're going to be creating in this tutorial video. The FPDF library is used to generate PDF documents in Python programming language. The FPDF library needs to be first installed in the shell or terminal of the Python IDE, which is MarsCode, by writing the statement below. And the statement is pip install FPDF. Then afterwards, you need to insert the import statement as well. And the import statement is from FPDF, import FPDF in capitalized letters. Now the statements to insert when writing data to a PDF document, because this library is responsible for writing data to a PDF document and generating that PDF document, include the from PDF import FPDF statement that we've already seen, PDF equals to FPDF, which creates the PDF object, basically just like creates the PDF file where you're going to be writing to. And then pdf.addPage, which then starts to add pages in the PDF document. Then afterwards, you can now start setting the font and the font style and the font size for whatever you want to write to the PDF document. How you're going to do this is by writing pdf.set_font. And then in parentheses, you're going to write the type of font style you like and the size as well of the text you would like to write in the PDF document. Then you have pdf.cell, and then here you have to specify how long, that means the width. So you can see 200 there. That indicates the width of the cell, which is where you're going to be writing that information or data or text, and the height, which is 10. So it's just like, think about it like a box, and you're going to be writing inside of a box. So you have to specify the width of the box, and you have to specify the height. The longer the width, the bigger the number, and then of course the taller it will be, again, a bigger number. So afterwards, when you've put the width and height, then you put a comma and then you write the text that you want to write in that cell. And here you can see we're writing MarsCode enclosed in quotation mark. Now with the cell, you can position the text by using LN, which represents line. So where would you like to put that text? And here you can see we're putting it in line equal 1, so in line 1. You can also align the text, so basically you can align it to the center, to the left, or to the right. And here we're aligning it to the center, so we're using C. So you basically just have to use the letter C for center, L for left, and R for right. Now afterwards, we're also trying to put an image in this PDF document, so we're using the statement pdf.image, and then in parentheses, we're putting the name of the picture. So this picture has to be existent in your program first. And then you can put the name of your photo here so that the compiler can access the picture to put in the PDF document. We also specify the X and the Y coordinates, that means the X and the Y positions of where you want to put this picture in the PDF document. You can see that there's a slight difference with how you put image or how you position image as opposed to how you position a text or information you're writing with the pdf.cell method. With the pdf.cell method, you are using line, but with the image, you're now using the X and Y coordinates. So just like you know how X and Y coordinates work, it's more negative on the left and positive on the right for X, and it's more positive at the top for Y and negative at the bottom. After you've specified your X and Y coordinates for the image, then you have to specify how wide you want the image to be. So you can see W equals to 100, so the width, and how tall you want it to be, so height equals to 100. So again, if you increase the number, it's going to be wider, and if you increase the numbers on width and height, it's just going to be wider or taller. Now afterwards, we have this pdf.output, and we're putting file1.pdf, which basically is just going to create that PDF document based on what you've included. And as you can see here, we've included a text MarsCode, which is of a size of 15 and a font style of Arial, and it's going to be in a cell on line 1. And then we've also included an image as well, which is also going to be positioned in a certain area on the document. Now let's look at the output of what would happen if you run this code. This is what would happen. You can see the output is just writing MarsCode at the top, and it's pretty looking small because, you know, the size we specified was 15. You can also specify a bigger size, and then you can see the image that we also inserted, which is that pic.png. So the picture is also here, and it's positioned in the position that we placed it in. So this is what would happen if you run that code. The next library we're going to be looking at is the Matplotlib library. The Matplotlib is a Python library that helps visualize and analyze data using graphical and pictorial visualizations. So we're going to start looking at the line graph, how you can create a line graph using this Matplotlib library. What it basically does is just to create line graphs pie charts, and bar graphs, and that's specifically what we're going to be looking at in this video tutorial. The following import statements and methods are used in Matplotlib to create line graphs. The first thing you need to do to be able to use this library is you need to install it in the shell or terminal of your Python IDE, which is the MarsCode IDE. The statement you're going to be writing is this pip install matplotlib. After that, you're going to have to include this import statement, which is import matplotlib.pyplot as PLT. And what that does is instead of you writing matplotlib.pyplot every time you want to be able to assign something to your graph, you can just say PLT instead. It doesn't have to be PLT. You could say import it as something else, but PLT is just a shorter name instead of writing matplotlib.pyplot. The next thing we're looking at is how to insert x-axis values. That means the values for your x-axis. And here what you can see is that I create a variable x equal and sort of a list here where I name out all of the values that are going to be on the x-axis. So I have A, B, and C. And each of those are in quotation marks because they are letters. You then need to insert your y-axis values, and here you can see the y is 5, 12, and 25 that corresponds to those x-axis values that we've just inserted. After you've specified your x-axis and y-axis values, the next thing to do is to plot the x and y values. To do that, you're going to write that PLT that you imported the pyplot as, and you're going to say dot plot, and inside of a parenthesis, you're going to specify the variable x, y. Afterwards, you're going to be labeling your x-axis, and you can see to be able to label it, you have to write PLT again, .x label, and specify the name of your x-axis. So that means what's the name of the values that you're having on the x-axis? What do those values represent? And in this case, we can see that A, B, and C represents pot numbers. So we're talking about like plant pot numbers. Imagine you are basically trying to create a line graph for a science experiment that you've done to basically see how the different sorts of light bulbs affect plant growth, for example. And you have 3 different pots, and in each pot you have a certain amount of seeds of a specific plant. So here you're specifying the X label for that x-axis, which is the pot numbers. So we're talking about the plant pot numbers being A, B, and C. And then you're specifying the Y label, which is the plant length in centimeters, so how tall the plants have grown being subjected to different types of light. Another thing you can use in the Matplotlib library is to also specify the title of your graph. And here we can see the title as natural fertilizer versus plant growth. So it's kind of the same thing like I said about the light bulb, but now just imagine instead of subjecting different plants to different sorts of light bulbs, you're kind of subjecting them to different type of natural fertilizers like banana peel or compost, and you want to see which plant's going to grow better with which type of natural fertilizer. So this is like the title for your graph that you're going to include, and if you want to include a title, you have to write that plt.title. Now, if you want to include legend in your graph, assuming you have more than one data to show on the line graph, you can put plt.legend, and here you see that we only have one legend, which is the plant growth basically, because that's just what is showing. But if you had another graph, perhaps for like maybe you're trying to create different growth trends for different type of seeds of plants, maybe you wanted to show plants, banana seeds, and not banana, but bean seeds and tomato seeds, and then show how the growth progresses as objective to different type of natural fertilizers, then the legend will be very useful there because you can specify the legend to show the different type of plants, to indicate the different type of plants. But in this case, we only have one legend, which is just the plant growth, which just shows how the plant grows, and that's it. You can also put this plt.show, so this is optional if you want to show the graph in your program, and if you prefer to just save the graph instead of showing it, which is what we're going to do in the MarsCode IDE, then you can just write plt.savefig instead, and what savefig means is like save figure or save picture, and in this case we're saving it as a PNG. You have to give the name of your graph that you want to save based on all this data that you've entered. And here you can see that the graph we're giving is graph1. The name is graph1.png. And now if you look on the right side, you're going to see the output of all what we've just included in our code. If we were to run that as a code, this is the output you'll be getting. You can see the title there saying natural fertilizer versus plant growth. You can see the legend inside of this graph box, and it's plant growth and represents the color blue. And then you can see on the x-axis we have A, B, and C, which represents where A is plotting at 5, and then B is plotting at 12, and C is plotting around 25. And then you can see the labels as well, like I said, on the x-axis plot numbers, and on the y-axis you can see it as plant length in centimeter. And that's pretty much the result of this program. When you run it, you're getting this line graph. But it's not just line graphs that we can actually get with the Matplotlib. We have many options. The second option we're going to be looking at is how we can be able to insert pie charts. Now, to insert pie charts, it's kind of the same thing again. The first thing you'd need to do is to import that matplotlib.pyplot as PLT statement, to write that statement down first, to type that in. But the only difference with the pie chart as opposed to the line graph is that we're going to also use another library called numpy, and we're importing this numpy as an NP. Now, if you do run the program and you do get an error on the numpy, then that means you have to install it as well, just very similarly to how you install the Matplotlib library, which is pretty much in the pip, or just by saying pip install numpy. But by default, it normally should be installed, or at least there should be an automatic suggestion to install it. But anyways, we're going to use that library because it helps to create arrays. The numpy library is used to work with arrays. And arrays are just like lists where they store data values that you're going to use to plot in your graph. Now here you can see once we've imported the numpy library as NP as well, so instead of putting numpy all the time, we can just represent it as NP or as something else you would like to represent it as. We're going to start off by putting the data values, and you can see here that I'm putting the y equals to np.array. So you basically just have to write it that way. And so inside of the square brackets, we see that we have 4 different values, 35, 10, 20, and 15. Those are the values that we are wanting to plot our pie graph based on, or a pie chart based on. And then we also have labels that indicate the meaning of those values. And here we can see we create this list called labels1, and we say equals to apples, bananas, cherries, and dates. So those different type of fruits represent those values that we have, 35, 10, 20, and 15. That could be just the amount of those fruits that are available. Let's say you want to show that in a pie chart. The next thing we also have is how we can actually plot the pie chart. So once you've specified the values that you want to include in your pie chart and the X labels, that means the titles representing those values, the next thing you want to do is to write plt.py, and then parenthesis, you're going to specify the data values, like the one that we saw in terms of numbers, and then comma, the labels themselves, and that would be labels equal labels1, which basically means the titles for those values that you're indicating as y, which remember the y was the numpy array that we created to put like the numbers 35, 10, and so on. And then we did create another list called labels1, which then contains the labels that represent those numbers, in this case, the type of fruits. And then afterwards, you're going to put a comma and a start angle at 90. You can start angle at 180 or 270 or 360 or 0. It's just where you're specifying where exactly the pie chart's going to be starting to be drawn from. So that's what the start angle does. Afterwards, once you finish that, the next thing to do and the final thing is just to save your pie chart. So you can put plt.savefig, and then you put the name of your pie chart, and as you can see, the name given is pie_chart.png. And if you run the program, this would be the result. Like on the right side here, you can see where we have apples in blue, dates in red, cherries in green, and bananas in orange that signify what those numbers that we've indicated are, to explain the significance of the labels themselves. So that's how you can create a simple pie chart using the Matplotlib library. Now we're going to look at a third type of graph that you can create using the Matplotlib library, which is the bar graph. So similarly to the line graph and the pie chart, For the bar graph, you also have to include that import statement. And here we have this import matplotlib.pyplot as PLT again. And you notice here again, we're using the NumPy library, but this time we're going to use the dictionary to be able to specify the values that we're going to be using. So because this is a bar graph, and know how bar graphs work, where you have to have an x-axis and a y-axis, just similar to a line graph, but the only difference is that it's just going to be displayed as a bar graph. So for that reason, we are creating this dictionary called data, and inside of this dictionary, we're having the first data, which is Python in closing quotation marks, and its representation, which is 50. So we can think about this like you're trying to find out the number of students enrolled in these courses. And we found out that for Python, there's 50 students. For Java, there's 30 students. And for C++, there's 20 students. So we have the key and the values in that sense. Because when you're dealing with dictionaries, and this is how you create dictionaries in Python, just by writing the name equal to curly brace, and then just indicating the key and the value of what you want to include in your dictionary. And here, as you can see, the key is Python, the value is 50, and then we see the key is Java, the value is 30, and the key is C++, and the value is 20. Now, after doing that, what we need to do is now split the keys from the values, and as you can see, we're using a list to do this. We're creating another variable called courses, and we're saying courses equals to list, and in parentheses, data, which is the dictionary that we created, dot keys. And those keys is a method that's just used to extract only the keys. So it's just going to extract that Python, Java, and C++. And then the second variable is values equal list data.values, which means you're trying to extract just the values from the dictionary. So instead of Python, Java, and C++, you're trying to extract 50, 30, and 20. So we're basically splitting the keys from the values so we can use it to plot the pie graph. The next thing you see here is we're creating another variable called fig, and we're using this plot or plt.figure. And for the bar graph, it's a little bit different as opposed to the line graph and the pie chart. Here, you have to specify how wide you want your bar graph to be and how tall you want it to be for you to be able to see the data. And we've specified using this plt.figure, and in fig size, we said equals to 10,5. So 10 pixels with 5 pixels height of how you want to show your bar graph picture. Now afterwards, the next thing you want to do is to now plot the bar graph. So how you do it is by saying plt.bar, and then you indicate what you want to plot against. So if you remember, we had the variable courses, which represented the keys from the dictionary, as opposed to the values, which represented the values from the dictionary. So you just have to indicate those two things, courses, comma, values. The color is equal to blue color. You can specify the color of the bar graph you want to be able to insert, whatever color it is. Just enclose it in quotation marks. And also you can specify the width of how wide you want the bar graphs to be. And here you can see I'm using a small width, which is 0.2. And then finally, you can now specify the name of the label on the x-axis. And here it represents the courses offered. And so you can see plt.x label, and in quotation marks, we're putting courses offered because that's the label, that's the text that's going to go on the x-axis. On the y-axis, we see that the text that's going to go there is no students, number of students enrolled, or no.students enrolled, which is a shorter form. And that's what you can see on the y-axis title. And finally, the title of the bar graph, what you can do is just by specifying plt.title, it writes students enrolled in different courses. So it basically is telling you that this graph shows you the different student amount that are enrolled in different courses. And then finally, if you want to save the graph, you got to write plt.savefig again. And in parentheses, you're going to specify the name of your graph. And here we can see it's bar_graph.png. So that's basically the name of the graph that you want to be generated once you run this entire program. As you can see in the bottom here, we can see the graph is already run, and this is the result. You can see the title, students enrolled in different courses. You can see the title for the X labels, which is Python, Java, C++, and then courses offered. and you can see the title for the y-axis, which is basically the number of students enrolled. So everything that we've seen, and if we run it, this was pretty much going to be the output of our program run. So that's it about the 3 different graphs that we will be probably using in this tutorial video to create programs, which is the line graph, the pie graph, and the bar graph as well. Here's a combination of creating a program that contains the use of FPDF, which is used to generate a PDF file, and also the Matplotlib library. So what we're doing here is the diagrams that we just created, or the graphs that we just generated in the previous slides, we now want to put them in a PDF document, and this is how you can put images or information in your PDF document. As we already know, the first thing to do is to import the FPDF library, but making sure you've already installed this with REPL, or you've installed it on your shell or terminal using that pip statement. The next thing is we have PDF equals to FPDF. We're creating an object of the PDF class so we can be able to add a page, and then we can start adding information to that page. So we add page next, obviously, and then we set the font. The font we set is Arial, and the size is 30 because we want to write that title, as you can see on the right side, that says MarsCoding. And again, to be able to write any text in your PDF document, you have to use that pdf.cell statement. Here we can see that we're specifying the width of the cell 200 and the height is 10 again, and then comma, put in the title name, MarsCode coding, and then putting the line, this is line 1, it's going to go on line 1, and aligning it to the center, which is align equals C. Afterwards, we're putting in the pictures of all the graphs that we created, which is pdf.image. The first graph is image.png. That was the name of the line graph. So we're putting that picture in the PDF, and we're specifying the x and the y coordinate. It's going to be at x equals to 5 and at y equals to 30. And then we're specifying the width and the height of the picture as well.